Okay, let's start with a wild thought. What if our entire understanding of the universe, everything we think we know, is built on a fundamental flaw? We're about to dive into a radical new theory that suggests the biggest mysteries in physics aren't just missing pieces of a puzzle, they're a sign we've been looking at the whole puzzle completely wrong.
So to get why this is such a big deal, we have to start with the single biggest mystery in all of physics. Just look around you for a second. Everything you see, stars, the planets, you, me, this screen, all of it makes up less than 5% of the entire universe. So what on earth is the rest of it?
For decades, science has basically had these two, well, placeholder names for all that other 95%, dark matter and dark energy. Here's the problem, though. Despite spending billions of dollars and running countless experiments, we have never, ever directly detected a single trace of them. They're complete and total phantoms. Now, look, this isn't just some small gap in our knowledge. A growing number of physicists are starting to argue that this massive, ongoing failure points to something way, way deeper. It's not just about a missing particle anymore. As this research proposal puts it, it could be a terminal flaw in our foundational understanding of reality itself. And that right there brings us to what some people are calling the cosmic crisis. It's this growing, nagging feeling that our standard model of the universe, for all its incredible success, might just be built on a foundation of ghosts. All right, so here's the crucial point you gotta grasp. Our current physics sees the universe kind of like a play. You've got the stage, that's space-time, and then you have the actors, that's all the matter and energy. The actors, they move around on the stage, and their weight can bend and warp the stage, but here's the thing, they are fundamentally separate. But what if that core assumption is the whole problem? What if the missing actors we've been searching for just don't exist at all? This is where this really radical new proposal comes into play. It suggests we've completely misunderstood the nature of the stage itself. And this is where the new idea just clicks. Instead of a stage and actors, forget it. There is only the stage. Just one single, unified, elastic fabric of reality. Everything we see and experience, matter, energy, forces. It's not an actor on the stage. It's just a wrinkle or a wave or a fold in the stage itself.
Okay, so if this fabric is everything, what's it like? Well, the theory says it's three-dimensional and it's always in flux, always changing. It has its own density and its own elasticity, and that can change from place to place. And here's the most important part. Its own natural behavior is what gives rise to everything we call a physical law. So for instance, the stiffness of the fabric in one area could be what determines the speed of light there. The law isn't some rule written on the universe, it's a property of the universe.
So how does this whole single fabric idea actually solve the mystery of dark matter? Well, it completely redefines the problem. See, we've been searching for a missing thing, when maybe we should have been looking at a missing behavior. Think about Einstein's famous field equations for a second, like a balancing scale. On the right side, you've got all the matter and energy, the actors. On the left side, you've got the geometry of spacetime, the stage. For almost 100 years, we've tried to balance that scale by adding a new actor, dark matter, to the right side. This theory says, nope, you're looking in the wrong place. The solution has been on the left side all along. It's a feature of the geometry itself. And here it is, the big reveal. What we call dark matter isn't matter at all. It's a geometric phenomenon, these huge, slow-moving waves propagating through the very fabric of reality. We haven't found a new particle because there isn't one defined. It's just a ripple in the universe itself. And what's so cool is that this simple idea has some serious explanatory power. For instance, recent measurements have shown that our galaxy is moving at different speeds depending on what you measure it against. How's that possible? Well, because we're not just moving through space, our entire galactic neighborhood is literally surfing on these giant waves, and the motion of that wave is getting added to our own. Okay, so that's the cosmic scale, giant waves explaining dark matter. But what happens if we zoom way in, like all the way down to the quantum level? What about the tiny little particles that make up, you and me? Right. That's the next logical question. In this new view, particles aren't separate things either. They're just different kinds of shapes, these incredibly complex, stable wrinkles or twists in that very same fabric of reality. To really get this, let's look at a classic puzzle from the quantum world, the electron and its heavier cousin, the muon. They share almost identical properties. Their fundamental shape is basically the same. And yet, the electron is for all intents and purposes eternal, while the muon just poof, it decays in microseconds. Why? Well, this theory offers a surprisingly simple, almost physical explanation. It's all about the resources you need. To create the shape of a muon, you have to gather up and twist a much larger volume of this reality fabric. And just like a really big, complex sandcastle is way more likely to collapse than a smaller one, this larger, more intricate construction is just inherently less stable. And this is what's truly incredible. This simple idea about geometry gives us a tangible, physical reason why one of the cornerstones of quantum physics, Heisenberg's uncertainty principle, actually works. That famous rule that links a particle's mass to its lifetime, it isn't just some abstract mathematical law. It's a direct consequence of the physical stability of these shapes in the fabric. So, if any of this is even close to being right, it's more than just a new theory. It's a completely new paradigm for physics, one that reframes everything we thought we knew. It basically suggests there are two layers to understanding the universe. The first layer is what reality is, that one single unified fabric. The second layer is how we humans interpret it. And here's the kicker. All of today's physics, from general relativity to quantum mechanics, all of it belongs to that second, interpretive layer. And when you really stop and think about it, the implications are just absolutely mind-bending. It means that things we thought were bedrock, fundamental constants of the universe, like the speed of light, are really just behavioral properties that emerge from the fabric. Space-time itself isn't the foundation of reality. It's just a local, emergent experience. Our most cherished theories are just different ways of looking at the same single thing. Which leaves us with this final, profound question. If everything we know, particles, forces, even space-time itself, are all just different shapes and wrinkles in one underlying fabric, then what is reality really? This new way of thinking doesn't just ask us to find new actors. It challenges us to finally understand the stage itself.